Right. You need to know the graphs of the three kinds of functions that we learned in this chapter, right? Exponential growth, exponential decay, and logarithmic functions. And in particular, the things you need to know are the shape, the domain, the range, the asymptotes, and the intercepts. Those are the details we're looking for on the graph. This was no, this is not the quiz question, because I didn't give you exponential growth, I gave you the decay. But in this case, this is just the basic exponential growth graph. By shape, I mean, what is the shape of the graph? It looks something like this. Right? It's growing, it's increasing from left to right. I'm going to jump down to the asymptote. It has an asymptote on the x-axis, which should be sketched in, right? You needed to dash it in so you can see it and label it y equals 0. Right? What is the y-intercept? You could clearly see it's crossing the y-axis. What's the y-intercept? Right? It's 1. I mean, you can't tell it from the graph because I'm drawing the graph, but it would be whatever you get when you plug in x equals 0. Right? What is 3 to the 0? 1. Yeah, anything to the 0 is 1. Okay. Now, if there was a number in front of that, for example, if it was like 2 times 3 to the x, then it would be 2. Right? If there's a coefficient in front of that, that's the y-intercept. But for this one, that's it. So we mark it and we write it down. It's 1, or you could say 0, 1, even better. Okay. What is the domain of that function? All real numbers, because you could see the arrow goes to the left and it's going to the right. I mean, really, the important part of domain is we're interested in domain because by knowing that the domain is all real numbers, that tells me I can plug in anything here. So when I'm deciding what I'm going to plug in, because I get to decide what to plug into X, I can choose anything. I'm not limited by anything at all. So domain would have been all reals. Right? What about the range? Does the range go infinitely up and down? Peter, you're forgetting something. It's got to be greater than 0, right? Remember, the asymptote, which is really on the x-axis, is a line on the graph that the graph of the function can never touch. Right? It can get infinitely close, but it can never touch that. Just like if I said, I'm gonna walk to the other side of the board by going halfway to the end with every step, right? In the first step, I'm here. In the next step, I'm here. In the next step, I'm here. I keep going halfway to the end. Am I ever going to get to the end? No, but I'm going to get infinitely close to it. That's what an asymptote is. It's getting infinitely close, but never touching the x-axis. So when I talk about the range, I can't say it's y greater than or equal to 0. It's greater than 0, right? Y greater than 0. And remember, range is y values. Don't say x. It kind of betrays a little bit of misunderstanding of the whole thing. So that's what we would put in for an exponential growth.